Hello again, welcome to this next video. As I already told you that we are doing some problems which were there in the last competition exams. So here we have a problem which was in uh, Canadian Open Mathematics Competition 2022. So look at this problem. The floor function of any real number a is the integer denoted by this is the notation for the floor function. You might have studied it already. And what is this function? This tells you that, like, if you have a number which is between the integers, like a and like it's less than a and greater than a minus 1. Okay, if you have a number like this, okay, let me tell, a and a plus 1. Okay, if you have any number here which is not equal to this is open, this is closed, then its floor function will be a. So basically, floor function of a number a tells you that what is the largest integer which is less than your number. For example, 5.3. I know 5 is the largest integer which is less than my number. Okay, 6, largest integer which is less than my number is 6, less than or equal to my number. 1.3 with a negative sign. If you look at this, minus 1.3 is here, and here is minus 2, here is minus 1, so it goes to minus 2. Okay, it doesn't go to minus 1, it goes to minus 2, because minus 2 is the largest integer which is smaller than minus 1.3, and so on. So that's the idea of this floor function, right? For example, they have given here that floor function of 5 is 5, floor function of pi is 3, because we know that pi is 3.14, and then similarly floor function of minus 1.5 is minus 2, as I told you this one. Okay, now we are good to go. This is just a piece of information which was given to you before the problem. Now the question is, find the difference between the largest integer solution of the equation this. So you have this equation, x by 3 floor function is equal to 102. You have to find its largest integer solution. Okay, so here you see, I just told you that what is this. This is, if you want this number's floor function to be 102, you want that number should be between 102 included and less than 103. Okay, like this, because if your number is like this, 102, 103, open here, closed here, then its floor function is going to be 102, right? So this is what we are looking for. So now if I multiply with 3, I know that I can multiply with 3, it will not change my inequality signs. So I'll get 103 times 102 times 3 less than equal to x less than 103 times 3. So that gives me 306 less than equal to x less than 309. Now because we are looking for integer solutions, so the integer solutions will be 306, 307 and 308. 309 is not included. Therefore, largest integer solution will be 308. Right? So that makes sense. So that is one part. We got the largest integer solution of this equation. Now read the statement again. You have to find the smallest integer solution of the equation this. So you have another equation which is saying floor function of x by 3 is equal to minus 102. Okay, so here if I want my floor function to be minus 102, then I have something like this, right? This included, this excluded. So I want this number x by 3 to be less than minus 101 and greater than equal to minus 102. Now again I multiply with 3, so I'll get minus 102 times 3 less than equal to x less than, it's not equal to, right? That's important, because when you are working with floor functions, you should know which part to be included and which part should be excluded. So this part here is excluded. So this is minus 306 less than equal to x less than 303 minus. Okay, now you have to see what are the integers here. So integer solutions are minus 306 minus, then you have minus 305, then you have minus 304. Minus 303 is not included. Now we are looking for the smallest solution. Now can you tell me what is the smallest integer solution here? You can write in the comment box and then you can check if you are right. So it is minus 306. It's not 304, right? Because it's with the negative sign. Now they are asking the difference between them. So difference between this here, the largest integer solution of the first equation and the smallest integer solution of the second equation, is going to be 308 minus, this is minus 306. So that gives you a 308 plus 306, and that is equal to, you can come find the addition. So this is 614. So that is your answer. So now if you look at this problem, it's not very hard problem. It's just that you should know what is your floor function, and that should be very clear to you that okay, we have to include the left hand side integer and we have to exclude the right hand side integer, because that makes all the changes. Okay, I hope you understand. If you have any doubts, please write in the comment box. Now let us look at the next problem. That's an interesting problem, and it's like a game problem. So what it says, a stone general is a chess piece that moves one square diagonally upward on each move. That is, it may move from coordinate a b to either coordinates a minus 1 b plus 1. So that's like this. This is the coordinate. If this is at the coordinate a comma b, then it can go to a minus 1 b plus 1 like this here, or it can go to a plus 1 b plus 1. It can go to here. So it can just move upside, not backwards. Okay, and that too diagonally. It cannot go here. This is forbidden, right? It cannot go here. It can just go here and here. It cannot go here, it cannot go here, and if it is here, suppose, then it cannot come back, right? Like this. This is not allowed. Does that make sense? Let me just erase this. Okay, so now now they are saying how many ways are there for a stone general to move from this position 5 comma 1. See, x is 5, y is 1. So this box here 5 comma 1. So this box is the position 5 comma 1 to the position 4 comma 8. 4 comma 8 is this, 4 here and 8 here. So this is 4 comma 8 in 7 moves, right? So you have to go from this position to this position in 7 moves, right? And on a standard 8 by 8 chessboard. So you have to make 7 moves, and you have to tell, you have to go from this position 5 comma 1 to 4 comma 8. So you have to tell how many such paths are possible. So first, like, try to understand the problem. So what we are asking here, so let me change the color, green color. So you see one path is like this, 1 2, this is my second move, third move, fourth move, fifth move, sixth move, and seventh. This is one of the paths. Okay, and then we can have like this, 1 2 3 4 5 6, and this is my seventh move, right? Then we can have another path, maybe like this. We can go 1, this is the same color, okay, 2 3 4 5 6 7. Like, there are so many paths. Okay, so these are the example of 3 paths which I have shown. So we have to tell how many paths are there. So you see, we cannot draw all the paths. That's not possible. Okay, so we should be having some mathematical, explanation of how many paths are possible. So now you see here what is happening, because you are going from this position to this position. So you see what kind of moves you have. So you have a move like this. What is this you have this north, south, east, west. So this is a northeast move. Or you have a move like this. You can see in all my paths here I have either this kind of move or this kind of move. So this is my northeast move and this is my northwest move. So I can choose any one of these two moves, right? And now because I have to final position, my final position is this way, right? So I should, out of seven moves, I should have four northwest moves and three northeast moves. Does that make sense? Okay, so that is for sure, because if you make something else, then you will not reach. For example, if I turn from here, maybe this move I make, then I am left with only two moves. 1, 2. I will never reach this position. So it's for sure that I need to have four northwest moves and three northeast moves. Right? And now there are seven positions. So it's like this, that you have seven moves like this. 1, 2, 3, 4, 5, 6, 7. I can fill them with northwest or northeast or northwest moves, but I want that out of these seven moves, four should be northwest. So if I choose 7C4, I choose four positions where I put my northwest moves, then automatically northeast moves will be fixed. So this is my answer. So what I have to do, out of seven moves, I have to fix my four northwest moves. So 7C4, so this will be 7 into 6 into 5 into 4 over 4 into 3 into 2 into 1. So that gives you a 35. So there are 35 total paths possible. Okay, so what I am doing here, I know that I have to make seven moves. So for example, what I am doing here in this, when I make for this particular path, I am fixing this 1, 2, 3, 4. Okay, then this is one path. Like how many, like if I'm looking for all the paths where these are the fixed, like northwest moves. Okay, so what I'm doing, I'm choosing how many ways I can fix my northwest moves. For example, this way is the one way to fix my northwest moves. Then this 1, 2, 3, 4 for the, this is another way of fixing my northwest moves. So I am seeing how many ways of fixing my northwest moves, and that is 35. You can also fix your northeast moves. For that, you have to choose out of 7, you fix your 3 positions. So that will also give you 7 into 6 into 5, 3 into 2 into 1. So that will also give you a 35. So that's also your answer. Same answer you will get, because it's the same concept, right? I hope you understand it. You can go through these problems once more, and if you have any problems, you can write in the comment box. Thank you for watching. Okay, bye.